Filtration is an essential process used in various industries to remove contaminants from liquids and gases. Today, we'll explore the fundamental mechanisms that make filtration effective. Screening, inertial impaction, interception, coalescing, and adsorption. And how they relate to the design of bag filters, cartridge filters, and activated carbon filters. Welcome to our second training video, brought to you by Clear Choice Filter to help you understand more about filtration mechanisms and how they are used to design the highest performing filters available. The first and most straightforward filtration mechanism is screening. In this process, larger particles are physically blocked by the filter material. Think of it like a coffee filter. Only particles smaller than the filter pores can pass through. In this case, the coffee grains are retained and the liquid passes through the media. Bag filters, which use a porous material, primarily rely on screening to remove debris, dirt, and larger contaminants from liquids and gases. Other types of filters that use screening are pleated filters that provide large surface area of filtration but limited depth of media. These filters are widely used in applications to protect dynamic equipment such as pumps and compressors, or even as a pre-filter to fine filters downstream because of their low cost. The next mechanism we will discuss is inertial impaction. Inertial impaction occurs when particles traveling in a fluid stream cannot follow the curvature of the airflow due to their inertia. As a result, they collide with and adhere to the fibers or surface of the filter media. This mechanism is particularly effective for larger, heavier particles and is widely used in air filtration applications such as HVAC systems and industrial air cleaners. This mechanism is applied to depth cartridges as well, to catch particles smaller than the pores of each individual layer of the filter depth. Next, we will discuss the mechanism of interception. Interception takes place when smaller particles, which can follow the airflow streamlines, come into direct contact with filter fibers and adhere to them. This mechanism is important in capturing fine particles and is commonly used in high-efficiency air filters. Other filter technologies, such as filter cartridges, also use this mechanism, especially those with some media depth. Next, we will discuss the mechanism of diffusion. Diffusion is a process that affects very small particles, typically below 0.1 microns. These particles move randomly due to Brownian motion and eventually collide with filter fibers, where they become trapped. This is the dominant mechanism in HEPA, high-efficiency particulate air, and ULPA, ultra-low penetration air filters used in cleanroom environments and medical applications. Natural gas coalescer cartridges also use this mechanism to catch the smaller particles. The cartridge shown here combine pleated and depth construction to provide the best of both technologies. We've covered all the basic mechanisms of filtration, being screening, interception, inertial impaction, and diffusion. Now we will move to the advanced filtration mechanisms of coalescing and adsorption. Coalescing filtration is used primarily for removing liquid aerosols from air and gas streams. Fine droplets are captured and merge, coalesce, into larger droplets, which then drain away due to gravity. This method is widely used in compressed air systems and oil mist separators. Adsorption is the mechanism used by activated carbon filters to remove contaminants, particularly organic compounds, from air and liquids. The porous structure of activated carbon provides a high surface area, allowing it to effectively capture volatile organic compounds, VOCs, odors, and chemicals. This method is commonly used in water purification, air purification, and industrial chemical processing. Cartridge filters are cylindrical filters used in various industries for both liquid and gas filtration. They are categorized into depth and pleated cartridges. Depth filters. These filters use thick media to capture particles throughout the entire depth of the material, rather than just on the surface. Depth filtration is ideal for applications requiring high dirt holding capacity, such as pharmaceutical and food processing. Pleated filters. These filters increase surface area by using pleated media, allowing for higher efficiency and longer filter life. Pleated filters are common in HVAC, water purification, and industrial gas filtration applications. Filtration is a critical aspect of many industries, and understanding the different filtration mechanisms helps in selecting the right filtration system for a given application. Whether it is screening, inertial impaction, interception, diffusion, coalescing, or activated carbon adsorption, each method plays a role in ensuring the effectiveness of industrial and commercial filtration systems. Additionally, selecting the appropriate filter type, bag filters, cartridges, or carbon-based filters can optimize performance and longevity in specific applications. This concludes our technical training session on filtration mechanisms. Thank you for your attention.